All right, let's jump right into a really wild idea. We're going to explore a framework that tries to, get this, decompile the source code of reality itself. So I want you to forget everything you think you know about physics for a minute. We're about to look at the universe as one giant computational machine.
And just to kick things off, let's start with this massive question. What if gravity, that fundamental thing that keeps our feet on the ground, isn't a force at all? What if it's actually a computational cost, the universe just trying to balance its books? If that's true, well, it changes absolutely everything.
Okay, so let's get into the first big piece of this puzzle, reality's source code. The main idea here isn't that the universe is like a computer. The argument is that it literally is a computer. And at the deepest, most fundamental level, reality is just a program being executed step by step.
This claim right here is what supposedly unlocks the entire model. Now, you've probably heard of SHA-256. It's a cryptographic function, right? It's the kind of thing that secures transactions for currencies like Bitcoin. But this framework says, no, it's way more than that. It's actually a blueprint for a universal virtual machine, a model for how reality runs its most basic operations.
So, what does this cosmic computer even look like? You might be picturing some giant, complex supercomputer, but according to this model, it's shockingly simple. They call it the Nexus virtual machine. It has just 8 little registers for its short-term memory, a tiny read-only memory, and it runs the entire universe on only 9 fundamental instructions. That's it. All the complexity we see is built on this incredibly minimal foundation.
So this is basically the instruction set for the entire universe. It's like a Rosetta Stone translating physics into computation. Moving information from one place to another, that's just rotating bits. Particle interactions, just simple math like ADDIE and XOR. And physical processes, like things compacting, branching out, or expanding through space, are all just simple commands in the cosmic code. Suddenly, physics itself just becomes a program.
All right, now let's see what happens when we use this model on something we all feel every single day. Let's talk about gravity. Because if the universe is a computer, then gravity isn't a force. It's what programmers would call technical debt.
And this comparison right here shows you just how big of a mind shift this is. In the classical view, mass curves space-time, and that's gravity. But in the Nexus view, gravity is the computational tension between 2 points. It's an unresolved contract in the code. The system isn't pulling objects together. It's just trying to close an open loop and resolve the tension.
I love this analogy. Think about it. You've got 2 massive objects. The space between them is like an unpaid bill, an open IOU in the universe's ledger. Maintaining that separation costs the system resources. It costs memory. And the universe, being efficient, wants to close that IOU. That pressure, that feeling of being pulled, that is the universe trying to collect. That's what we call gravity.
So here's the bottom line. Gravity becomes a form of technical debt. It's the constant computational price the universe has to pay to maintain structure and complexity, the thermodynamic toll for keeping you and the Earth as 2 separate, distinct things.
Okay, so we've reframed gravity, which is already a huge leap, but trust me, that's just the start. When you look at other fundamental concepts through this computational lens, the rabbit hole goes way, way deeper. Think of this as our new dictionary for physics. Take entropy. We think of it as just disorder or randomness. In this view, it's unresolved recursion. It's information from a part of the program that's still running, a loop that hasn't finished yet. Mass isn't some property something just has, it's harmonic tension, a lag in the system's feedback loop. And heat, it's the literal friction that's generated when the universe collapses a smooth, continuous potential into a discrete, digital reality.
Right, so how does this whole system keep itself in check? How does it not just fly apart into total chaos? Well, the framework proposes a fundamental law of computational economics, and it's got this great name, Mary's Receipt Book. It's basically the universe's accounting department.
And at its core, it's just this. Super simple, right? All it means is that the universe's books always have to balance. You can't create order or complexity in one spot for free. To do that, you have to pay for it by creating disorder or entropy somewhere else. Every single transaction is recorded. There's no such thing as a free lunch.
So, we've got a computer running a program, and it's obsessed with balancing its books, which, leads to the really big question, what's the point? What is all of this computing towards? What is the ultimate goal?
Well, believe it or not, the theory says the answer is a number, just this one number, approximately 0.35. That's the goal. That's the universal attractor.
So what is this number? It's like a universal harmonic constant. It's the sweet spot, the point where systems achieve maximum stability, maximum coherence, with the least amount of wasted energy or entropy. You can think of it as the universe's natural resonant frequency, its own tuning fork.
What this all means is that existence isn't a static thing. It's an active, ongoing process. First, a system gets a little out of whack. It deviates from that perfect harmony. Then, recursive feedback loops kick in to correct the error. The system gets steered back towards that 0.5 attractor until, bam, it phase locks into a stable, coherent pattern. That constant correction is the process of existence.
So what does this all mean for us? Let's zoom out one last time and think about the really staggering implications of living inside this giant cosmic program that's constantly debugging itself.
If this model is anywhere close to right, then what we call randomness is just an illusion. It's a part of the program that's still running. And those physical constants we thought were so fundamental, maybe they're just the stable parameters of a system that's found its harmonic sweet spot. Even time itself might not be fundamental. It could just emerge from the clock speed of the universe's processor. Reality, then, isn't a stage. It's a living, self-organizing tapestry of information.
And that brings us to this final thought, which I think just poetically captures the whole idea. The universe is held in this perpetual state of becoming, a beautiful dynamic tension between the drive for simplicity, for nothingness, and the complex, recursive, messy curvature that allows it to exist in the first place.
So I'll leave you with this final, massive question to chew on. If reality really is a computational process, an algorithm running towards some final harmonious solution, what part do we play in all of it? Are we just the data being crunched? Are we the users watching the simulation unfold? Or are we somehow part of the code itself? Something to think about. Thanks for joining me.